1.2 Motion Memo. Define speed. The distance travelled per unit time. Define velocity. Speed in a given direction, or alternatively the displacement per unit time. Question number 2. A truck travels 60 kilometers in half an hour. The driver rests for 15 minutes and then drives a further 20 kilometers in 15 minutes. What's the average speed of the truck during the whole hour in kilometers per hour? Well, average speed is the total distance divided by the total time. Well, the total distance is 60 plus 20 kilometers, and it's a total of 1 hour, so we get 80 kilometers per hour on average. Okay, question number 3. A car travels at 15 meters per second and accelerates to 25 meters per second over a period of 5 seconds. What's the car's acceleration? Well, we're going to use the formula that acceleration is the change in velocity over the change in time. So our final velocity is 25 minus 15 gives us a change of 10. And then it took a time of 5 seconds. So 10 divided by 5 is 2 meters per second squared. Next up, state the acceleration of free fall g for an object near the surface of the Earth. Well, this is now being changed to 9.8. It used to be 10, but it's now 9.8. What does the area under a velocity time graph represent? It represents the displacement. What does the gradient of a velocity time graph represent? It represents acceleration. What does the gradient of a displacement time graph represent? Well, that represents velocity. Number 6, a marble is dropped in a measuring cylinder filled with oil. As it falls, eventually it reaches terminal velocity. Describe the forces and resulting acceleration acting on the marble from the moment it's released to when the marble reaches terminal velocity. Well, initially there's only the force of weight, so the marble will accelerate at 9.8 or 9.81. However, the drag and viscous force will increase, eventually becoming equal to the weight force, and the marble will reach terminal velocity as the acceleration will decrease to 0. So the acceleration actually ends up going to 0. You don't decelerate, but you end up going down to your acceleration becomes 0 as you approach terminal velocity. Okay, thank you very much.